topic. James is recording this meeting for posterity, so just keep your language in mind. And other than that, I believe that's all I've got. All of you should be familiar with what Techlahoma is. If you get a chance, they've been doing a whole bunch of I think sponsor matched donor. So if you feel generous, they always take donations, and if you feel generous with your time, they'll also take that as well. So, Daniel, are you ready to go? Or
I'm always ready to go.
Awesome.
I've had my caffeine for the day. Coffee's still going. We're looking good.
Okay, James, you got anything before we hand it over?
Nope. And Daniel, you should be able to share your screen, no problems.
Fantastic. Cool. I'll go ahead and do that now and make sure everybody can actually see my screen.
Oh, wow. Okay. And away we go.
Cool. I do want to take a moment just real quick to explain, just if anyone doesn't know what Techlahoma is, and give my short spiel on Techlahoma.
Oh, go ahead.
Back in 2015, 2016, whenever I was getting started with Free Code Camp, I was actually working out of a library with just a handful of people, just self-studying and self-learning JavaScript and web development in general, and trying to help lead small user groups. And I found Techlahoma, and I mean, just an extraordinarily nice group of individuals, some of whom I formed long-term connections with. I heavily encourage, if you're not part of the Techlahoma community, this is my spiel and my pitch to you to contribute or just get involved in it. We're a smaller group, which means we tend to know each other, and I like it that way to a certain extent. And just in that same vein, this is a smaller group. I'm not doing a talk in front of, or a presentation in front of 300 people. I'm doing a talk in front of 14 or 15 people or so. And I want to keep it informal on purpose. I'm going to give you two pitches. One of them is that you should listen to me, and the other one is that you probably shouldn't listen to me and go and explore on your own. And you're going to hear that potentially throughout this talk, because I do not consider myself an expert in any shape or form. So today I'm going to give a brief overview and just some cool stuff to try to pique your interest about Moddable SDK. I've been doing more and more here lately with embedded devices, and in some of my going and digging, I came across Moddable SDK, and I really like it in its community. So that's why I'm giving the talk at all. My goal here is to have an informal conversation. This is not me preaching to you, or I'm not going to lead you line by line on how to install Moddable SDK. This is me basically purely trying to pique your interest, and then have a conversation afterwards about the stuff that I've done with Moddable SDK, the stuff that I might do with Moddable SDK, and also anything else I could potentially help with, or if anything piques your interest, we can just do an informal kind of Q&A round if you'd like. I want to go over why I was looking for the solution, what I personally think of it, and just in general how to use it. There will be code demos, and code demos always go terribly, but I promise if they go terribly now, I did test them before I do them live. So I swear they worked on my machine. That's trademarked. Who am I? My name is Daniel Ashcraft. I am currently a senior software engineer at Artemis Ag, and I'm going to give a short shout out to Cal Corbin, who is on the call, who will actually be joining my team on July the 20th at Artemis. So I'm super excited because we've got another Oklahomie coming into one of these West Coast and East Coast startups, and that's what I like. We gotta branch out and make some moves. Thank you, Cal, for even applying. There were only like 5 applicants from the state of Oklahoma in the past 2 years, and 4 of them made it to the final interview rounds. So please, if you see these jobs, don't disqualify yourself. Go ahead and apply because they're pretty excellent positions, just kind of in general. I also own a small development shop. I have a handful of customers I do development and software work for. I try to focus mostly on mid-stack and on the front end. And I don't do a lot of active consulting right now, but I do some active consulting for a handful of startups in the web community, in the web world. I am also a co-founder of a new startup called Juniper Garden, which is how I even got kind of started investigating some of this. I've been primarily a web developer, mostly JavaScript for 6-7 years now. And if you ask me what my current expertise are, it's probably gonna be somewhere in the React Native world, because that's what I do on a day-to-day basis. So it's the most fresh in my mind. And I have been a Techlahoma member since 2015, 2016. I haven't been super active as of late, mostly because for a long time I was doing talks like every single weekend. And as you can imagine, it got very, very exhausting. And also I wanted to let other people have their turn. So I took a step back, but I love the Techlahoma community. I think it is fantastic. So don't take my inactivity as a denouncement. I actually really, really enjoy the community. I'm kind of behind the scenes talking to people. Yeah. So how did I get here? I started with, and this is the boring part. So like, if you're not interested in non-code stuff, you can like tune out, you can switch it off. But I've got a lot of spieling to do before I get into code stuff. Because I want to, once again, entice your curiosity. I started a startup in particular because there's a pretty big problem right now. Well, I consider it a problem. Some people don't. In agriculture and really just in like embedded devices in general, which is the big three are really starting to move in. And if you want to do anything with these devices, it usually comes with a whole host of terms and conditions. And good luck if you need support. And they're usually overpriced, and they usually don't do everything you want them to do. So forth and so on, and so forth and so on. So in having some issues actually with existing customers in agriculture, there's a lot of problems right now with on-premise solutions not actually having cloud providers or cloud solutions. And there's not a really equitable way of getting your data off of your on-premise solution into the cloud, at least not without paying, those good old corp-to-corp fees that tend to be in the tens of thousands of dollars. So in seeing that, I started doing some digging, and I was like, well, sensor ingestion is something I've solved locally and for a handful of the other businesses I've worked for. This can't be that difficult of a problem. And lo and behold, I kind of got started investigating the hardware side of it, and it got a little crazy. So I, in a lot of different areas, came across Moddable SDK, mostly because I am a JavaScript developer. And what I love about the JavaScript community is our ability to iterate really quickly and share code. We in general are pretty open source centric. And that was one of our biggest hurdles for us as a company, because we wanted to make sure that whatever solution we came up with, we could provide it, free of charge without violating terms and conditions and so forth and so on. We really want to be open source first. Basically, if like it's not super secret sauce that would violate, our customers' privacy, we want to do our best to be super open with this. So the exact opposite of almost any other IoT company, for the most part, out in the wild. And yeah, that's how we came across Moddable. I'm going to give you short pros and cons so that, if none of these interest you in particular, you can just go, hey, this was a cool talk, and we'll discuss it afterwards. Pros are, this is a big one, is it does have its own debugger environment. You would be surprised how many tools in the hardware industry don't really have a debug environment. It's more like, run at your own risk and, hope it doesn't blow up. I enjoy debugger environments. I'm pretty used to debugging things like this in Chrome DevTools and in the Node.js debugger. So having a debug environment was super important to me. It was a really cool pro. That's why it's all caps, because it's cool. Same thing for emulators. You'd be surprised. There are not a lot of hardware emulators, mostly because it's kind of hard. It's a hard problem to solve. If you ever run Android Studio, and anytime you run Android Studio or something like VS Code and the simulators there, you're basically single-handedly contributing to global warming, probably significantly. So the resources are intensive, and it's very, very difficult. In fact, a lot of companies just on their own make their entire living off of emulators. So if you've heard of Sauce Labs, all Sauce Labs does is like emulators for Android and so forth and so on, and simulators. Pros are going to be JavaScript, and there's a question mark there, because if you don't like JavaScript, you're probably not going to like this talk. If you're a Ruby person and you just despise JavaScript, you're not going to like this. It is JavaScript. So another pro that I really want to talk about is the community at Moddable. I personally am one of the kinds of developers that I really enjoy non-toxic communities and communities that are really open. Being a non-hardware developer, getting kind of involved in the community, I'm going to say a lot of stupid things and use terms incorrectly. And it's really a positive experience whenever I can do that and people aren't just going to kind of like shoo me away. Because I can also be kind of annoying when it comes to asking those kinds of questions. This community is super welcoming. I've interacted with a handful of people, especially on their Gitter, and also on their GitHub discussions board. They are all super welcoming. It is an awesome community, and I really enjoy it. It's one of the bigger pluses. The other pros of Moddable SDK, in my opinion, is faster development time. If you've ever programmed in C++, which I've done very little of, there is a little bit of a you take a pretty good development cycle hit in terms of development time for some of this. It could also because I'm biased towards JavaScript. It's faster for me to write JavaScript, but I think just kind of in general, I would say it's a known that it takes a lot longer to iterate on C++ than it does a JavaScript application, for better or worse. Cons are going to be out of box board support. They have a whole host and a really well documented list of the devices and boards they support, as well as a handful of documents over how to go forth and add additional board support and do that, which was not something I'm super familiar with, but I know that in particular, I was interested in the 8266s and the Espressif particular platforms like the ESP32, which is super awesome. And this supported that. The other cons are the initial setup for the Moddable SDK isn't super great, but it's also not super terrible. What I would say is I probably couldn't like walk my wife through how to install this, but for most people that have been in development world and done any kind of command line tool installations, this won't be terribly difficult. I'm sure as the community grows and over time, this could get possibly a little easier, a little better. That's just going to take time. The other cons are it seems to be a somewhat smaller community. The other platform I've done a little bit of work with is going to be ESP Home, which is like the home assistant Hasio Nabukasa company. And because they're an organization and they have home assistant, they've already got a ton of buy-in. They're a low code / no code type platform though. So there are trade-offs to that. But compared to that community, this community is a little bit smaller. I wanted to just give a general graph, and notice there's no numbers here because this is me being hand wavy and like issuing my opinion on things, depending on your development ability. So for your primary coding language, this may change for you. C++ Arduino tends to be super highly customizable because once again, you're kind of like programming on the device and really close to the metal. But the dev speed tends to be a little slower. Your iteration speed tends to be a little bit slower, in my opinion. The middle ground I found was kind of like the GoBot. GoBot doesn't have a lot of extensibility right now. They don't support Bluetooth, for instance, which was an issue for me, at least for doing things like Bluetooth onboarding for Wi-Fi credentials. They don't currently support that, and they're just a little bit behind. But Go is a pretty cool language, and I can write Go pretty fast, and it's got some development tools too that kind of help things move along. ESP Home, which I mentioned, which is like a low-code, no-code solution. They actually use a YAML config file. They have the ability to do customizations, but it's not inherently straightforward how you do that. And it's a little bit kind of like, reminds me of the Rails world, where if you want to do something outside like the paradigm, you kind of got to do it the Rails way and kind of like tweak it in and make it work. So in terms of customizability, it's pretty low on the list, only because you're further away from the metal. ESP Home uses, I believe, Python that goes through Platformio that produces C++ that gets like turned into something it understands, something like that. Once again, TLDR, not an expert.
It actually also does Arduino on top of that.
Okay, so there's another step that I missed.
Well, yeah, so it's like Platform IO, then Arduino actually takes Arduino. Actually, what it is, it's your low code, no code Arduino, then Platform IO, then somewhere down the line there's a GCC compiler, and then it's on the device. Yeah,
so there's a lot of intermediate steps, and as you can imagine, if you're going to write custom code and you're not doing it like their way, you're going to run into some issues. And then up here on like the top right is actually where I would put Moddable SDK. You're pretty close to the board. much closer than ESP Home. In terms of development speed, I've felt like a lot of the current skill set I have transferred over really well. So it was fairly easy for me to get kind of started working in Moddable SDK. And their actual support of all the expressive tools, just kind of in general, and expressive packages is very high. And in fact, you could go through the documentation and take a look at their examples, and it's just a plethora of options for different networking protocols. You'd be surprised how many of these different services don't offer something as simple as like a socket server. But I mean, if you dug through all the abilities to actually like network things in hardware, especially with 8266s and 32s, you'd be surprised how many kind of like features get left out because there's just not a lot of buy-in or support or code, or just not a great developer network. So that's even why I'm talking about Moddable SDK, because I put it kind of in that top right sweet spot, in my opinion, depending on your needs. This is where I kind of talk in hand-wavy terms a little bit about the XS engine, because I don't know a ton about it outside of the fact that it really feels like Node.js. And I like that it really feels like Node.js because I like Node.js. It's okay. So there's setup options for Windows, Mac, and Linux, your primary operating systems. Like I said, it has a whole plethora of supported boards. Some boards aren't supported, but like I said, it does have some documentation. I'm sure there's ways to go and, customize the board layouts and so forth and so on, as long as like, I guess the architecture platform is supported. There's a lot more high-level documentation that I'm not personally good at or familiar with that you can go and investigate. As far as support goes, in my experience of the issues that I've had, they've been resolved in a matter of like half an hour to an hour, which is for a smaller community, that's kind of unheard of. But everybody on Gitter, on GitHub discussions, even on Twitter, are super responsive. And I really appreciate that, because I will bang my head against the wall for so long, but eventually I'm just going to move on to like, coding something in Tetris or P5JS or something, because I get bored. Maybe I'm an ADHD developer. Anyways, so they're super responsive, and I appreciate that. And they're also super nice. Like I said, a really warm, welcoming community. And from a JavaScript perspective, I really like that as well. You don't really, we won't get into old guard stuff, but they're I'm sure if anybody has done any level development, they've run into, hopefully not, but probably have seen some toxic stuff in communities. This community has none of that so far as I've seen. Licensing, it's LGPLv3 for open source. I'm not a lawyer. I read these documents in passing, make sure that if it says like use a FOSS compliant license to do so, but I'm not an expert on the intricacies of this. So make sure that if you have licensing requirements that you do so. I do know that of the options that do have like a for-profit motive or a for-profit license, theirs is super awesome. A lot of the for-profit licenses have either like an upfront fee or they have a pretty large yearly fee. Moddable SDK is fairly straightforward. It's 0.20. It's a quarter a device for for-profit ventures. So if you're not doing open source work and you like put this on a device and then you go and sell it, then you have to pay 25 cents. And that is probably at that point, if you're going to be making money off of it and you're going to be building a company around it, you should probably have a one-on-one conversation with the people you're taking the technology from. So that is, the onus is on you to go and make sure that you're going to be compliant, and judging by the community, it's probably not going to be an issue. My argument is for the JavaScript developers with us today. This is like my call to you. Just in the brief time that I've been doing IoT, or like even investigating hardware in general, it really feels like the Wild Wild West, and mostly by the Wild Wild West, I mean Amazon owns everything. So there are classic old guard problems, there are classic new problems, and this is a pretty good opportunity for the web development community, which is very large compared to the embedded community, to help iterate on things like standards, or even help contribute to dev tooling or create dev tooling, and just in general, try to help keep some of this nice and happy, and preferably as open source as possible. However you feel about the big three, contributing to open source in general is always a good idea. Something that kind of struck me by surprise was that FreeRTOS got sponsored by Amazon or whatnot, and that kind of turned me off on a handful of other solutions. And like I'm not sure about the implications of that, but I know that given the opportunity, I would prefer to kind of have as much control over my end product as I possibly could, because once again, I'd like to give away a lot of it for free, and I don't want someone coming telling me that I can't give it away for free, ideally. I also want to just point out that JavaScript devs in general are focused on developer tooling and developer experiences. I feel like web developer experiences are really, really high quality. If you were a developer 10 years ago and you started doing web development today, I feel like the tooling has gotten a lot better. And if you've been a web dev for greater than 10 years, you can chime in. I feel like also as well that Node.js in particular and their community is very open source driven. And Moddable SDK has a lot of opportunity for open source contribution. And I've been doing some open source contribution for Moddable SDK and trying to bring some of those cool web packages that I personally enjoy to help speed up my own process. So if you want to do that, this is kind of your call to arms to go and like do that. Go and contribute. Go and like rewrite, some Lodash functions that you want to reuse or something, and do it the moddable way. There naturally going to be differences. And one thing I want to say is, like, if you are a JavaScript developer in the web community and you come into this world, I feel like it's an interesting problem to solve. Because you now have like CPU, resource problems and memory resource problems. And I feel like it will make you a better overall JavaScript developer, because you're going to be using a lot of the raw core fundamentals versus like importing a package, because those packages don't exist yet. So yeah, go and give it a try. And like I said, you're going to learn something. The community is great. And yeah, you might even get some recognition for it. And you'll see a shameless self plug for the package that I wrote. Here in just a few. So this is I've just given you like a lot of the reasons why, for the most part, like, hey, I'm a senior dev and like I do all these web things and stuff, but this is my big blurb that I am not an expert at using Moddable SDK. But the team at Moddable has literally written a book for you. You can go and purchase this book over how to use the SDK in detail. There's a lot of focus on things like screens and LEDs and touch screens. I think that's super awesome. I won't be using a lot of it personally because I'm doing a lot of sensor ingestion stuff. But I find that really neat, that I could probably, recreate my Honeywell thermostat and probably do it better and give it all the features that I want, and not ever have to worry about it connecting to like, my Prime driver that's driving down the street. Thanks Amazon and Amazon Echo. Yeah, literally they wrote a book for you. There's very few platforms that go so far as to give you that much information or dedicate that much time to showing you how to use their particular platform. So take advantage of that. And yeah, it's not very expensive. I think it's like $30. That's what I want to say, something like 30 or 40 bucks. Considering like some of the books at Barnes & Noble for tech stuff were in the 80s, 90s, 100s, it's not too bad. So yeah, I'm going to show you some code. And this is the part where it becomes even more informal. This is where bugs can happen. But before I like literally show you the code that I wrote, I want to just take a moment to go over, like, their documentation is very thorough about installing it. I'm not going to show you how to install it, but they have detailed instructions that are step by step for each operating system. Whenever I went through these steps step by step, the only issue I had was that I had like 4 versions of Python on my machine, and that's my fault. That's not their fault. So that was the only issue I ran into. So more than likely, if you install Moddable SDK by these steps, step by step, you're not going to have an issue, and you're going to get up and running pretty quickly. I think all in all, even with my issue, I was up and running in about 30 minutes. So yeah, that's there. And then this is the board I'm particularly using, which is the ESP8266. The ESP8266 and ESP32 require different tooling. So if you use a different board, you got to make sure that you have the tools for that board. I went through these steps, installed it, and like I said, once I got it up and running, it worked great. They also have examples that you can run in their emulator so that you know that it's actually running like it's supposed to. And last but not least are all the tools that they've created. Once again, this is a pretty good dedication to just tooling in general. You're not going to find, at least in my experience, this level of tooling from an individual company around their SDK or their libraries or their platform it's going to be a lot more shallow than this. Either that, or it's going to feel like it was kind of like done back in the early 90s. But yeah, they've got a lot of command line tools as well as a handful of like nicety tools. And the ones that I particularly enjoy are going to be the simulator and then also the debugger, which I will be running the debugger here shortly, and you can take a look at that. But yeah, I'm going to go ahead and pause before I start showing code so that I can answer questions if we have any that are just super brief and high level. Because I know once I get into code, the people that are not super familiar with just JavaScript in general, or maybe not ready for it, are going to kind of tune out. I want to make sure that I answer any questions before I just like jet forth into the cool stuff. No questions? We sure? All right. Cool. Well, I will go ahead and show some code. So the first piece of code I'm going to show you, and once again, this is going to look really familiar because it really just works like Node.js, damn near out of the box. So this is a super simple application that creates an access point so that I can create an MDNS server and I can send back a JSON response. Remember that this device, which I'll actually show you the little ESP, little tiny, how much do these go for again, Lawrence? These are like, I think $4 a piece, $5 a piece.
Yeah, it depends on where you get them from. You can buy them in bulk from AliExpress for super cheap, but recently it's like under $10 for a module.
Yeah, so you get a Wi-Fi access point. You can run sensors off of these for like $4 and some change and a little bit of time on a weekend. Try to do that with like a Nest thermostat or something. Like it's just like, it's a little bit of work, but I mean, that is powerful stuff. Even like my web brain is like blown at just how much you can do with so little resources these days. And 32 is even better. Do I have my ESP32? Hey, I do. Thank you, Lawrence. Actually, I have one you gave me the other day. The ESP32 is a tiny bit more expensive, but this one has Bluetooth capabilities, and it's a little bit faster. So this one is, I think, like $6 to $8 a pop. Very inexpensive. Show the code. Cool. Yeah. So in Moddable SDK, I'm sure in Node.js world, just in JavaScript world, you're used to package.json. Moddable doesn't have npm. So you have instead of manifest.json, where you can include packages from the Moddable SDK in particular, and you can tell it how to build your stuff. Once again, this is the part where I do the hand wavy stuff where I'm like not a Moddable expert. I know that it has a handful of caching mechanisms. It has ways of, for memory reasons, including files that aren't going to be like held in RAM, or they're just going to decrease the amount of resources necessary to hold files, for instance. Moddable SDK supports over-the-air updates. So you send a device out in the wild, connect it to the internet, and you can set it up so that it will receive updates to its binary and program over the air, which is super cool. Once again, like the capabilities these days just blows my mind. In this particular one, I have my own package I created called Express.js mod. I include the packages it includes. So just imagine it has a package.json file, for instance, and you're importing it into another one, so it knows what files to include from the SDK as well. I preload Express.js mod. I was told to do this. I don't know the explicitness of it, but I was told to do this and it works. So I'm like, yeah, that's cool. That's awesome. This is including just the modules in general. There's also a way, if you're really hip to it and you know C, you can write C and include C files and run those. Another demo I have that I scraped from their examples and kind of like hodgepodged it with my own stuff. It does use C to restart the device whenever you give it an access point. Because you imagine you like turn on the Wi-Fi and then you like change it and you want to connect to the Wi-Fi instead of like giving an access point, you got to like restart it so that it will connect to the internet. I will look at code now. So yeah, this all looks like, you know, if what, ES 2015 probably. I'm not super up to date on my, I don't remember which one introduced the import syntax, but one of the JavaScript ones, one of the ECMAScripts levels that brought in the import scripts. Yeah, it looks just like Node.js. I don't think anybody here that does JavaScript is unfamiliar with what this looks like. Moddable SDK and the XS engine, which is like we have Chrome V8 for obvious reasons, that's just engine for JavaScript in the web. They have the XS engine, which is the JavaScript engine for embedded devices. They've done a pretty good job of keeping XS kind of a one-for-one carryover from just our normal syntaxes that we're used to, so that the similar web standards apply. There are differences. They've done a good job of actually documenting a lot of the differences. So if like you use something that doesn't behave as expected, which is very rare, I have not even come across that as of yet. But if you do use something that doesn't behave as expected, there's plenty of documentation to go over that will actually like show you the differences and why they're there. So yep, I set up an access point. This is what it's going to be called whenever I go to connect with my phone here in a second. I give the access point a password, create a server. This is my own package and also a shameless self-plug to please go and contribute and make my code not suck as much. This looks just like Express. It actually kind of makes me giggle that the interface is so similar. And yeah, this is the MDNS. MDNS it's not that big of a deal, not super important to this talk, but I didn't want to type in IP addresses, so I just gave it an MDNS name. So now I can just go to ESP8266.local and get the information I want. So that's the code. Now I'm fixing to start running the command line interface and the debug environment. Does anybody have questions about the code? I mean, it looks just like JavaScript. That's what I love about it, because I like JavaScript. We actually have Yuri on here too as well, and I talked to him briefly about this particular SDK because I was contemplating using Rust. There's another company doing some cool stuff. So hey Yuri, this is the thing I was talking about. Cool. So I'm gonna go ahead and pop open my tools, and you'll notice that these are the 86 native tools for VS 2019. This is part of the build environment you use with Moddable SDK. So fairly straightforward. I'm going to go into web demo. I am going to run the debugger, and I'm going to tell it that the platform is for ESP. I know that D is debugger and P is platform. I forgot what the M means, but I run it every time, so I'm going to keep running it so that my environment doesn't crash for some unknown reasons. So right now that's writing to this device I have that's connected to my USB port. And it's going to go through and create that wireless access point that I can connect to with my phone. If I connected to it with my desktop right now, it would kill the Zoom call. So I'm not going to do that. I made that mistake once whenever I was doing this demo for my company internally, and I'm going to avoid doing that on this Zoom call. Give me just one moment. I'm going to make some screenshots so that Lawrence can share them in Eventbrite and also on the Slack channel. But basically, I now have a wireless access point called ESP8266 access point, and I got to type in the password. And let's go to the root. Let's go ahead and share that real quick. It's always magical when something works the first time. It didn't crash. So I automatically succeed at this talk, by the way, because I did a code demo, I ran it, and it didn't crash. So you were all witness to it. And if Techlahoma has like a Speaker of the Year award, I want that award. Demo didn't crash. Here you go. Lawrence, I'm gonna go ahead and send you that screenshot. It's pretty simple. This just sends, like I said, a JSON response. We can actually go through and debug this. I haven't debugged in a while. let's throw a debugger in here. I want to say the syntax is probably going to be the same as Node. And this is, oh my Lord, this is when we look and we're like, oh, we have two people in the audience who happen to be from Moddable SDK. So I get to wave at them and be like, hey, does debugger work the same in Moddable SDK as it does in Node.js?
So you can put a debugger statement, yeah, and you can also set breakpoints in XSBug if you open the file in there. You can set and disable breakpoints as you go.
Let's put the debugger in there. I'm going to run it, and then let's see if I can hit it real quick. So now we're famous. Cool, so that's writing to the device again, and it's updating the code on there. And I'll wait for that to run.
Did I see briefly like a profile of resources being used by the device?
Yep. Yeah, it'll break down memory usage. It'll let you know, I believe, like how many sockets connections or how many network connections are being made. The debugger is pretty awesome. Let's see if I can go back to that real quick. So yeah, it's pretty cool. Once again, not something else you get with a lot of the other platforms that you could choose from.
Yeah, so this is actually really cool from an embedded standpoint. So this is actually running on the device itself, or is this in simulation, or?
Yep, this is running on the device itself.
Wow. Yeah, so like all this information that you get, I guess, for free in this case, it's really hard to get from, usually from a other standpoint, because normally you have to, the channels to get this information from an embedded device are either through the like the debug channel through the like the JTAG interface, or the SWD serial interface, if you're ARM or not, or you're begging it over across a serial interface, which takes up a huge amount of overhead too. So it's interesting to see how they do it.
Yep, and you know, just in playing around with some of the other platforms, this was super awesome for me, especially because I'm so used to Chrome DevTools, and I almost feel handicapped when I don't have good debugging tools in other platforms and just code in general. So getting back to the code, I went to my device, I connected to the Wi-Fi access point, I went to the route, and the route has now stopped in the debugger. Once again, feels very similar to the Chrome debug tools. I can go through and, just as I would similarly to how I do in Chrome debugger tools, be able to view all the things and all the variables that I've created. It is so awesome. And then I can also continue, and it will continue. I cannot tell you how much of a better experience this is compared to some of the other platforms. You're gonna have to go out and try it for yourself, and I would suggest even like trying out some of the other platforms as well. So this one was super simple. This is just a little web experiment, and also shameless self-plug to please go contribute to this and make it better. It just sends a JSON message. We can get a little more complex, so let's go ahead and do that real quick. I'm going to go into sensor demo. So I don't know if everybody can actually see, because once again, it's kind of small, but I have a BME 280 temperature, humidity, and pressure sensor attached to this. Thank you, Lawrence. This is, so it's a little bit more in ESP8266 because that's what I had handy. But effectively with that, you could create your own local web server if you wanted to, not running from your device. So you could put it on your home network, put it anywhere you wanted to, and think of all the cool stuff you can do. So let's go into sensor demo, and let's go ahead and write this. The sensor demo, I'll show the code real quick. I did not write this BME 280 code. I actually found a GitHub repository that had a BME 280 class on here, and I will share that GitHub repo in Slack to make sure I give them proper kudos and respect for that. But yeah, somebody's already gone through and actually written a lot of that, including like the oversampling rate and buffers and all the cool, and I'll actually show the code real quick. So they went through and did all the hard stuff, and as a JavaScript community is want to do, I used it to do the stuff that I really wanted to do, which we need more of, by the way. So JavaScript developers, please contribute. So yeah, this one does a very similar thing. The only difference is I have 2 endpoints now. I have one that's a get route that just sends a hello world message, but now I have a /data endpoint that will send back the payload for the temperature sensor every time I request that this endpoint. So let's go ahead and run this one. Actually, I'll go ahead and start that with the debugger statement in here so we can take a look at the payload, because that's what we do. We fly by the seat of our pants and write code that works, and we go forth and conquer. All right, now I'm getting that written, and see what we can do. And the very last demo, I'm going to do something similar, but I'm going to go ahead and connect it to my home network, and then I'm going to pull all the code away because Cox Communications does not allow me to create a guest Wi-Fi access point. So I can only use my actual Wi-Fi credentials, and I don't want to blast those to the web. So on the last demo, I'm going to like move it off the screen, ideally. Otherwise, you can all come and enjoy my Wi-Fi sitting in my parking lot, or perchance nefarious things, which is why I won't show it. Cool. So this is created the server. It's done the same MDNS thing, so that I don't have to type in the full IP address. I'm going to go and connect to it and pop in here. This one worked, and now I'm going to hit the data route, and this one should hit my debugger. And there we go. Cool. So that was, I was using my cell phone, by the way. So I can go here and I take a look at the payload, and I can see that, you know, the humidity, pressure, and temperature coming back seem to be relatively accurate. So if you had to do some tweaking, once again, this is a great way to get insight into like what data values are actually being returned. I've experienced a little bit of issues, like if your sampling rate's weird or like something, the way that you set it up is off, which is why I have awesome people like Lawrence in my life to help me fix these things. This at least gives me insight to go, hey, that temperature says that I'm as hot as the sun. It's probably not accurate. So yeah, if I continue through, it will return it on the screen. There we go. Cool. So that is the debugger environment. I'm going to go ahead and pull my code over so you can't see my Wi-Fi credentials. And hopefully I can get this working for the one that actually connects to my network. I felt like this is the one time where I like share and it pops up on the wrong screen. It's like, you know, someone's Wi-Fi credential. So let's stop that. All right, let's share the screen again. Let's make sure that it connects to the Wi-Fi real quick. Just to be clear, nobody can see my Wi-Fi credentials, right? Sweet, awesome. Yes. All right, that seems to work. So if I come over here and I go to sensor local, I actually don't remember if I added a local point to that. I did not. Hey, I've got some stuff here. And let me see where I stuck the actual endpoint for what I wanted. Let's see here. Events. So if I go to events, here is the temperature sensor, and I'll prove to you that this is working. So you're like, oh, he's not faking it. My humidity is 46. If I wrap my hand around this, I'm just making the humidity go up and I refresh. The humidity is going to climb because my hands are sweaty. Hey, woo, demo that worked. I'm telling you, this is like if anybody's ever given a talk, this is unheard of. No errors. It's crazy. So yeah, that's my demo, and the code for that is a little bit longer. Using the Express package that I wrote, it's not as bad. I kind of, in that package, I abstracted out a lot of the code that does some of the other stuff. Give me 2 awards for 2 working demos. That's what I'm talking about, Tanner. That's what I'm talking about. But yeah, as far as code goes, and I can go ahead and just show, let's just do Express.js mod. We can take a look at the code that I wrote just so you get an idea of like what it looks like to actually write code. This is TypeScript, so if you're not familiar with TypeScript, it's not a big deal, but most of this is just plain JavaScript. There's no special extension. I don't have, you know, any super crazy configs going. I don't have like Webpacker compiling to something else, or maybe even Babel. It's mostly just plain TypeScript and a little bit of hand wavy stuff. And really, this is all it took. So I was able to kind of bring one of my favorite packages from Node.js over in relatively short order. And I hope we have more people in this room that will go and attempt to do the same. So yeah, that's all I have for the demos. We are, some of the other cool stuff I'm going to be doing with this will be writing to a streaming server. I have plans to create a media streaming server, which is going to be a pain, but I've got a little bit of experience using FFmpeg, and I'm hoping I can do some stuff with that. They have some demos in the Moddable SDK demos that go over how to use I think it's the Apple media server, not Apple media server, but basically like connecting your Apple device to an ESP8266. And they also have a demo where they use a screen to do that, which is super cool. So yeah, I would highly, highly suggest, I mean, you just pop in and just take a look at all the different examples they've got for all the different kinds of network communication and protocols. Super thorough. I could not be happier, even though they're on the, I didn't even see that they were on the line until just now, but even though they're in the room, I'm still going to say that the SDK is awesome. And I was super excited when I came across it as a JS developer. And I highly encourage everybody to go and investigate and play around. And that is my general talk for today. I just want to make an informal discussion Q&A. Whatever you want to ask. If you want to ask about my company, you want to ask more about Moddable, this is the open time. I'm here for you.
I mean, I got some technical questions.
Oh no.
So I guess my first question is, do you know what real-time operating system is underneath the hood for all this? And if it doesn't have a real-time operating system, how does it handle real concurrency and timed events or time-critical events?
I know from digging through the docs that free RTOS is still mentioned. I didn't really have a big issue with, and we talked about this too, you know, quite a bit, but I didn't have a huge issue with the Amazon free RTOS issue. For those that aren't familiar, like you can set up IoT devices through Amazon now, and they're a pretty big contributor, if not like the primary contributor to free RTOS now. They basically, I would say own, but I don't know if own is the actual technical term. But I believe they still use it. So I don't have a problem necessarily using that technology. It seems to be the golden standard. So everywhere I look, even on Espressive's own website, free RTOS is kind of like the way to go. So yeah, as far as I know, that's what they're using under the hood.
Yeah, not to step on your toes, but that's basically right. So we use kind of whatever the native platform is for the board that you're looking at. And so on the ESP8266, that build is using the Arduino core for ESP8266. On ESP32, we're building directly on top of the ESP-IDF, which is a FreeRTOS based hardware abstraction layer that Espressive built for their hardware. So hi, I'm Andy, one of the co-founders at Moddable.
Hi, Andy, and thank you for helping me with my ESP32 build issues.
You bet. Glad we could get you going.
So I guess the other questions are, how does, I know you've got ESP32 support, but what about all the other alphabet of processors available? How easy is it to port over new processors, and how is it easy to port over new boards?
It's pretty straightforward. So with the kind of ARM-based microcontrollers, generally you're writing kind of a thin little porting layer. So there's a porting guide in the XS documentation on our GitHub that kind of talks about what you need to provide, and it's basic things like a socket, implementation, a way to write a file and read back a file, a way to write a preference and read back a preference, a way to get a random number. Yeah, things that you would expect to have on each board. And you provide that kind of little layer for ARM. You can kind of just start with the ESP32 implementation. We also have x86 implementations for like Raspberry Pi, things like that. And then if you want to bring up something more exotic, it would be more work. But honestly, most of the time when we're bringing up something new and wacky, it's getting the tools to play with the build tools. That's the hard part. It's not actually running on the device. So for instance, if you look on our GitHub right now, we have a Raspberry Pi Pico build bring up going on. That's kind of a community bring up. And there, almost all the work has actually been on the tooling side, not on kind of building and linking for the Raspberry Pi Pico.
All right, thank you.
Yeah, Lawrence, take that. How often are you going to get the Nabu Kasa co-founder to come over here and talk to us about ESP Home? How about that, Lawrence?
Yeah, probably not very often. Yeah, I've done a couple of, I've used like RioQS for a number of years, and it's been one of those things where it's pretty well supported. Most of the build-up processes are usually not that bad. You should just need to go through documentation. The only places where I've ever had trouble is like in some of the like the very obscure like custom modules that are embedded into various devices. Like for example, the often included, not very well documented math code libraries in the Nordic family in particular, where people are all of a sudden discovering that all their devices happen to have a DSP built into them. So they're like, oh wait, I can use this for IoT and machine learning and like very light neural networks because some engineer signed the contract with ARM to have those features in their chipset when they licensed them all, and then they sat dormant for years until somebody realized that they could actually use them for something more than just math processes. So that's all the questions I have.
I'm sure you have more, Lawrence.
I do, but I just don't want to take up all the time.
Well, I'll talk briefly about the direction I'm currently taking it. Nabu Kasa and Home Assistant in particular has a new Bluetooth onboarding protocol. Not really a protocol, but a standard that they want to use. And it is called, oh, if I can find it, that'd be great. It's called Improv. And it's basically just a standard Bluetooth characteristic for onboarding to make it compatible with Home Assistant. Home Assistant is pretty popular. By pretty, I mean, like in terms of open source, it is really popular, especially with hobbyists. So of the devices I want to create, I want to make sure that hobbyists, enthusiasts, and just people in general, if they don't want to use like the middleman platform we plan on creating, they don't have to. I feel like a lot of companies want to kind of be the bridge troll or like own the data. And in the particular startup that we co-founded, we want to avoid that. Whenever somebody owns a device, we want them like literally own the device. Part of that also means like letting them do with their data what they want. So if they want to use Home Assistant with the device or so forth and so on, they can. And so with something like Moddable SDK, I'm not like limited in creating these Bluetooth characteristics, whereas when another platform, and there's another platform that did this, they can kind of like hamstring you into using their particular service characteristic. There's not a lot of configurability in that. But with Moddable SDK, it doesn't matter if I use ESP Home to spin up half my boards or Moddable SDK to spin up half my boards, because the overall interface can stay consistent, and those Bluetooth services for onboarding, for instance, can stay consistent. So that was pretty cool for me as well. Yes, I can tell you more about my company. Well, I guess this is like a first kind of sort of big reveal. Is that right, Lawrence? Like, it's definitely the most we've ever talked about it.
I mean, we talk about it, we just don't really talk about it.
It's, yeah. So in particular, with my current company does compliance management. Hey, Warren. My current company does compliance management for crops, and in doing compliance management for crops, I visit growers all over the United States, and we've got a couple in different countries, and they all kind of have a similar issue, which is, oh lordy, their devices are super expensive and they can never get their data where they want it to go. And in order to get their data where they want it to go, they usually have to pay a pretty hefty fee. There are a handful of services that all kind of do the same thing, but they all want to own your data. And I think some of that might be a byproduct of just them, being venture capital invested. So it's very difficult to 10x your company if you're not charging people, everything that you possibly could, or at least not for their data. So our company's kind of operated under the premise that we want to kind of do everything where most of it is free. If not everything as possible is for free. So we're going to have a robust free program where if you use these devices, which we're starting mostly with around garden automation, because that's where I have the most expertise, especially around sensor ingestion and just other things. Right now we're in the monitoring phase. So we're doing temp, pressure, and humidity. We have plans for developing a in-tank EC sensor that will be completely wireless. We have plans for potentially leveraging LoRa and other technologies out in the fields for long distance agricultural implementations where they have like 40 acres. You're not going to get Wi-Fi out in the middle of nowhere. We basically have plans to either open source all the schematics, try to use open source boards as much as possible, and let people dictate where their data goes. If they happen to use our ingestion service or our mobile app that I've been working on, we'll have a fee for it. We'll have a free plan. And then after as soon as it starts becoming cost prohibitive for us, we're going to start charging for it, which is actually surprisingly inexpensive. The current test I'm running on our ingestion server is very cheap. It's like $20 per stream, and the stream can handle like 10,000 connections, and that's quite a few. So yeah, from a high level overview, we're focusing on monitoring. We're going to pivot over to automation for garden specific environments while open sourcing schematics as much as possible, open sourcing code as much as possible, and having robust free tiers and giving complete and 100% total ownership of the end product to our customers, because we don't want to be like John Deere and Caterpillar and all these other companies where you don't really own your product. You kind of just temporarily rent it until you got to fix something, and then you got to pay the piper. So that's, I guess, is high level of an overview without like talking about individual like implementations that I could give you about my company. So yeah, we're gonna give a lot of it for free, and hopefully somebody puts us out of business. That's our goal, is like we want a company to come along and be like, hey, we're gonna do everything better than you. We're gonna open source more stuff. We're gonna like give more of the product away for free, because there's no reason why we should be charging like $2,000 for a $40 controller, like and just put us out of business. And that would be like the best end result, I think, in that we could have. So if you can't tell, pretty disrupt oriented. Do I use JavaScript or another language? We have a handful of languages we're currently using on the stack. On the web side, we are using a combination of Rails, just because it's fast to implement. We have a Node.js ingestion server. For the mobile app, we're using React Native, which is actually going really well. I've been sending demos to Lawrence ad nauseum. I'm sure he's tired of seeing them by now. And then for the actual ingestion portion, and this is once again part of like the whole give away the information as much as possible. The ingestion portion is a combination of AWS API Gateway and AWS. Using AWS Firehose, and I'll just pull up the stack real quick. Not literally, I'm just going to pull up the tech. But yeah, I'm using a combination of Let's log in. Please log in. Yes. Yep, AWS Kinesis, that's what it's called. So it's Kinesis that basically serves as like the buffer for the data coming in and the ingestion. That goes to AWS Firehose, which writes to both Amazon S3, and then it also gets triggered in AWS Firehose, sends data to the node ingestion server, and that will run super simple outlier removal of the data per individual, per company, or per device, or per reading, and then that will store in a Postgres database. So we have S3 that stores all our raw data. So if our customers, for instance, ever wanted to just have access to the raw data to run machine learning against, we can spin up AWS Lake Formation and give them credentials to only their data. And it still allows us to run our linear regressions and remove outliers on our data that goes to Postgres. And you can formulate alerts. We can also do computed values. A big problem right now too is there are a handful of computed values that get used for sensors that are literally just computed. One of them is VPD. VPD is a combination of humidity and temperature and a handful of tables that it gets converted to. And you'd be surprised how many really expensive products that do temperature, humidity, and pressure don't have VPD access. And I really wanted to make sure that our particular data model supported that. So to go over those languages in particular, it's Ruby for one server, Node, which is JavaScript on another server, and React for our normal front end, and React Native for the mobile app. And then AWS is literally just all connecting services. The benefit of having the API gateway is that it kind of serves as a proxy. So if we want to move from AWS, we can literally just point that to another place, and it's just gonna get proxied to somewhere else, to some other buffering service. I am on Slack. So we have the Techlahoma Slack. I have my company Slack, and so forth and so on. So lots of Slack channels. In fact, I've recently had to start deleting them because there are so many, and I think everybody kind of feels that pain if they're on Slack and it's part of more than one community. I think I've still got like 14 Slacks I'm on. Thank you, Kimberly, and I'm glad Kimberly is here, even though we can't see Kimberly. Yes, Warren. So I'm using React Native to do everything. There is going to become a point where I can't use Expo Go, which is for the simulator, on my device, because I am going to be using some experimental building. Bluetooth right now is handled through React Native BLE PLX, which is like a third-party package using native code for Bluetooth for React Native. That doesn't play nice with Expo by default. You have to use these special build tools that basically break their playground environment. So right now we're doing Wi-Fi onboarding through the platform, and I can share some screenshots of it. It's pretty cool. But yeah, most of it is done through Expo right now, and it will continue to be done through Expo. I just won't get the cool emulator. Once I implement Bluetooth and it uses native code, I have to use EAS build and then the iOS simulator and Android simulator. Yeah, as far as React Native goes, I don't. If it's React Native, I choose Expo by default these days. The development experience is just a lot better, and I really like the development experience. React Native is still super useful, but I just honestly despise Xcode. And I do a lot of my development on a MacBook, and if I could ever avoid using Xcode, if at all possible, I try to, because it hurts. It honestly, they've done better, but it just hurts every time my MacBook Pro spins up. I just can't do anything else. It's pretty bad. Yeah, Cal. So whenever you on board with Artemis, we're using Xcode. We don't use Xcode to do anything. Luckily.
Yeah, and so it wasn't obvious that I'm doing the hardware. So I design electronics. This is the board we're currently working on. And this is a first revision, our second revision. We're finishing up and that one does temperature, humidity, and sensor pressure. And there has been all sorts of fun things I can tell you about the current part shortage and finding parts and developing the most flexible and tiny board possible. So.
I'm still surprised you were able to fit all of that on that little bitty board. So like I took a picture of it in the palm of my hand because I think it's maybe like 1.25 inches. How big would you say it is, Lawrence? It's tiny. It is tiny.
Yeah, the actual tricky part about it is actually not only getting the size right, but also making it robust and cheap to manufacture. So this is actually a single-sided board. So when it goes through manufacturing, it's all pick and place on one side. There's no double side to go through reflow. And also I'm designing it currently to be, well, for one, I was going to originally do an optically clear coat for the whole thing, so you actually could see the board underneath. But I'm also looking at options for doing maybe like a blackout version of it, where it's all like basically solid block. But the manufacturing side of the designing for manufacturability is actually a huge part of doing all this. Because literally, like the moment somebody touches this board, you can basically like literally see the dollar signs just pop up. So the idea is to basically make it as like push a button, spit out boards, and then ideally they fall into gracefully the packaging, and then like you spend maybe 5 seconds to like put on a shipping label and shove it out the door. So it's been very educational.
I'm so glad you're handling all of it though, because as soon as we hit hardware, I am out. Not my expertise. You know, I know the limits of my abilities, right? Like I think that's important to know what you don't know.
Yeah, the sentiment is mutual. The moment you started talking about AWS, I'm like, I think the first time I met you was we were doing I think I actually ended up like roping you into an AWS project, and like the amount of knowledge I had to pick up just to do the small bit I did, you've already like dwarfed it like immensely. So I'm just like, yes, take on all the web dev stuff, take on all the server stuff. I'll interject in with like some requirements, and at some point I'll want to do some like machine learning stuff on it. But I'm more than happy to have the web dev world handle as much as possible.
I'm just finally glad to like, I really just want to see a product on the market that does just a better job at like a decent, realistic price. Like that's really what I want to see. Like it really hurts whenever I hear about, someone having like a hardwired controller that was obviously built back in the early 90s and it's probably, I think I sent you some specs, and it's like, probably $150, $200 worth of real effort manufacturing, and they're charging, $5,000 for it. And then you got to pay a service fee. Then you got to pay for data transfer fees. If you want access to their cloud, you have to pay for that. And you can't ever leave them. And if you do ever leave them, you can't take your data with you. Like that kind of stuff that's why, yeah, that grinds my gears.
Yeah, and I've seen it a couple of times too, like just in other manufacturing environments from different like product lines. Like the reason why the reason why we're doing all this in the first place is because we needed a platform that we either was fully open that we could basically pull from, or we needed to own it ourselves so that we had control over different pieces of it. If there was a product that already did exactly what I wanted to do and it was the form factor I wanted and was industrially designed for mass manufacturing, then we probably would have gone down this route. But there really wasn't, not one that had all the documentation available. There's a lot of hobbyist boards, but they weren't really designed for industry. So that we kind of had to roll around for that regard. I mean, at the end of the day, basically what we want to get into is standards creation and creating a framework for all this. Because if you look at, I mean, the home automation scene itself has this problem, and the IoT market has this problem as well. But everybody creates their own standard for this type of stuff. And so there's actually like a graveyard of standards that people have like picked up, ran with, and then shut down, and then started up a new standard for the whole thing. So I think what we're looking at is working more on the open standards scene, and then being a community member as opposed to a gatekeeper is what we're looking at. And so it's kind of it'll be interesting to see how it goes. I'm hoping that the value add of being able to own your own hardware and having confidence that it'll be around in 10 years, because I've got a box full of hardware that is no longer supported. There's no documentation for it. The companies have gone under, and it's not useful anymore because of that. And I'm hoping that even at the end of the day, if this venture goes under, the firmware will still be available, the files will still be available, and if somebody wanted to like add another feature to it, or reproduce it, or build another 30 of them, they could go out and go through the effort of manufacturing them themselves, and do that without having to completely reinvent the wheel. And also, like manufacturing files, they get stale over time. So it's not like manufacturing files are a living entity. So the design effort that goes in the product today is good for maybe like 5 years max. After that, things go out of stock, things go out of style. It needs to be refreshed anyways. So it's one of those things where it really would benefit to having a community all building a product, and then the community itself support the product as it goes along. And there's going to be a huge market in manufacturing support, certification for compliance with the standards that we're helping to develop, and then a lot of business in that regard too, and just making sure that the product that uses, like for example, the Arduino platform, there are tons of Arduino boards out there, or Arduino clones out there, but very few of them, well, none of them are blessed by the Arduino moniker, except for like maybe a couple, but they're all underneath the radar. And when you buy a board, you don't have any guarantee that it's built to spec. It just says that it's built to spec. So being able to like have confidence that your boards, not only are they coming from whatever manufacturer you want to pick, but also have meet the specifications that the community as a whole have come to expect. I think that's going to be a really powerful additive or feature for this. So I'm looking forward to building it. Any questions?
Yeah, I just want my thermostat to like actually report to the same service as my Zigbee door lock. That's really what I want. I'd really rather not have like an app for every single different device that I have. That's really what, that's still like, yeah, that's what I want. That'd be great.
I think a lot of that's doable with Home Assistant. And Home Assistant does a lot of, that's the reason why we're looking at supporting it at all, is because it does a lot of the stuff that we want to do. It doesn't cover all the bases, but it does enough of them that is definitely worth supporting.
That's another reason why the ModdableJS SDK is so interesting, at least from my perspective too, is that adding Home Assistant is a choice I get to make. It's not kind of like made for me what platform I get to use. So it's not like the Zigbee standard or something. It's like, hey, here you go. Like do what you want and use JavaScript. So that's like, hey, I don't have to use or learn another language. That was nice. GoBot was interesting too, and I like Go I like Golang. Golang's fine. I like Golang because I know it a lot better than I know C++. The only thing I had is like there seems to be a really base level implementation of like every language for Espressive or their products, but none of them are really full featured. So that's another reason why like GoBot doesn't right now have the stuff we need for Bluetooth onboarding. So it doesn't support BLE. I think it supports like Bluetooth server or the old BLGAT, whatever it's called, but doesn't support BLE yet. I'm like, well, that rules you out. Like I immediately can't use your service. I need to go find something else. So yeah, whenever I pulled up in the examples folder and I saw like MQTT was there, sockets were there, SNMTP was there, HTTP. I was like, oh, hell yeah! Like I could do what I want. And you'd be surprised, for anybody getting into this with the 8266, it's like to get your data off of your home network. You got to do some digging. It actually takes quite a bit of work. To get your data into the cloud or wherever you're going to send it, that off-premise solution, it takes work. That takes effort. So when you use something like this, and you connect to your home Wi-Fi service, you can literally just connect this device up to a USB plug in the wall, and leave your house and be able to access your temperature, humidity, and pressure literally anywhere you want to go, really, depending, of course, on your skills with web servers. That's awesome. Like that right there already beats like a whole plethora of devices on Amazon right now where you have to be within Bluetooth range or you have to be on your home network. So yeah, once again, shameless spiel about go and contribute, because this kind of stuff and this kind of technology is super awesome. And I personally think this kind of technology is like mission critical for IoT. Like I've really, like 3 years ago, I never would have thought of IoT. I honestly thought it was mostly dead. Like 3 years ago, I really did. It's like, oh, this is it's Amazon Echo. And like, that's kind of it. I did not talk about, so Hong asked in the channel if I talked about any security aspects in IoT and JavaScript. I did not. Security is one of those things that I personally know enough about to know that I don't know enough about it. So that's something that, whenever we get into those aspects, we'll very likely either re-implement a protocol or standard that currently exists, or we will outsource to have a securities expert to come in and actually diagnose if we are implementing any vulnerabilities in someone's network by using our devices. I don't kind of play around with that kind of stuff because it is such a big deal. But no, I didn't talk about it during this particular talk. As far as code goes, the Moddable SDK does have, not sandboxed, I believe it's called SES. I forgot what the acronym SES stands for.
Secure ECMAScript.
Thank you. Secure ECMAScript. So they have some, at least, security around code in particular. There's another platform called Tuit that is using virtual machines to run programs in parallel. And that's nice and all, but it's a whole different language. And they do charge you for using their service. In Moddable, it'd be really interesting, and I hope the future in particular with Moddable is like borderline being able to run potentially unsafe code in like a sandbox environment. That would be nice from a playground sense. I would like to be able to like produce a device where if my customers wanted to like write a script that took my Fahrenheit and just made it Celsius for the hell of it, they could do that and they could play around with it without jeopardizing like the underlying code. But I actually don't know anything about that or how difficult that is. So yeah, I get to be like, hey, that sounds real pie in the sky. It might be cool.
Yeah, so that is very much the mission at Moddable. Hence the name Moddable. The company was kind of founded around this idea of building IoT products that were end user modifiable in a safe way. And so we do secure ECMAScript kind of sandboxes of end user code that can interact in controlled ways with the main application running on a device through a process that we call mods. And yeah, you can look on our website if you're curious about what we're trying to do there.
I'll post a link to some of the documentation about the SES related work and kind of the goal of it, how it works. But yeah, like Andy said, that is absolutely what we want to be doing here, is make it possible to add third-party code to applications or run third-party code on devices in a safe way, in a secure way. So there's a lot of work going on with that. I'll post some links.
I had a quick question. So I actually did a deep dive into Talk OS, TOCK. It's actually a Rust language based OS. It was actually interesting because it's built from the ground up on Rust. So unlike a lot of the other, so a lot of the other ones are basically, and I think Talk actually does the same thing where they wrap around like C, C++ for some of the drivers, because a lot of the embedded stuff is built on C, C++. But in Talk in particular, they've been doing a lot of interesting stuff with sandboxed, like mission or data critical and low memory projects. And the reason why I'm not using them currently is actually because when I last looked at them, they were in the middle of doing a transfer from, like, I think which version they were at, but they basically were doing a large major version switch. And so I was doing a project that involved needing to have like a stable version to work from, and they were making changes. They're making critical changes up and down the stack, and it wasn't something I could do or deal with. So my question, I guess, is how does Moddable work like Talk, and how does it work differently than Talk? Because I know that they're basically very similar. They just took a different they did take a different core operating system or language as their core, though.
So I'm only the very most minimally familiar with Talk, so I can't speak a lot to what they do. But my high level, my understanding is that that's a like full on concurrent operating system, right? That you can kind of just run multiple applications on. And that's not exactly what we're doing. So what we're doing is closer to, if you're familiar in the web world, you have kind of a JavaScript application and like web workers, where it's a quasi multi-threaded model for JavaScript on the web. We're doing something closer to that, where we're, instead of running like multiple applications on an operating system, we are running the like main XS engine and then spinning up additional instances of the XS engine to run other processes in, all in JavaScript and all kind of controlled within our ecosystem. And so it's more analogous to a single application with multi-threaded helpers than it is to multiple applications running on an operating system. And in terms of how like third-party code fits into that, we use the model of ECMAScript modules. So ECMAScript, JavaScript, has a built-in mechanism for importing and loading modules dynamically. And the way that we allow the kind of third-party code to run in a safe way is that we make it so that the main application imports only pieces that it wants from the third-party modules that get loaded into the system. And they call, functions or build objects from constructors. And now I feel like I need my cat. He's here somewhere. And we do that kind of all to build one big application that is a safe blend of trusted native code, trusted first-party code, and third-party code, rather than having kind of multiple applications running on an operating system, if that makes sense.
Yeah, I was kind of curious because I know that one of the problems that Talk has is that, so if you basically, the way they do they're basically sandbox every individual application. But the problem is that people immediately want to break that when they want to do things like save data. And how do you handle like data storage on an embedded device which has limited storage in the first place, and then have like different modules that people want to plug and play with? So one of the things that we're going to, and for most of the sensor application stuff we're doing, it's not that big of a deal because they can run asynchronously to each other, and real-time data critical stuff isn't as big a deal. But when we start doing things like control level interactions where the synchronicity of events, the timing of events will be mission critical. I'm kind of curious. It sounds like what I'd have to end up doing is with using Moddable, I'd have to basically write I'd almost have to write like a subsection that would do all of the timekeeping and act as a real-time operating system inside of that. Because it doesn't sound like there's an easy way to basically have multiple modules all work asynchronously and then synchronize on certain event queues for certain applications. And that being said, for device and resource limited devices, it's usually not that big of a deal because normally you'd have like a myriad of different devices and they can all handle their own applications, their own processes. But the one step up would be, let's say you've got like maybe a more heavy duty multi-core ARM processor and you wanted to use Moddable for the main operating system for that. Is it appropriate for that? It sounds like maybe not. It seems like it'd be more appropriate for more of the edge devices, the edge OS devices that live on the peripheral of things. If I'm hearing correctly.
So there were at least two questions there. To the first one, kind of how do you expose device and operating system resources in a safe way to third-party code? The way that we do that is basically by providing dummy or so JavaScript has a lot of built-in mechanisms for getting, time and date, for writing to files, for doing things like that. Secure ECMAScript allows you to remap and rebind those built-in primitives to whatever version of those the host application wants to expose to third-party codes to other modules. And so we do a kind of rebinding process where you can stick a mediator in the middle and filter requests to access the file system or to go out to the network or to access preferences. Those sorts of potentially sensitive tasks can be mediated by the host application that then brings in the third-party code. To the question of, is it appropriate to use the Moddable SDK on kind of full-fledged computing devices? Yes and no. I mean, as a general rule, we kind of tell people that where we shine and where we would expect people to be using us is places where you can't really run V8, places where you can't really run Node. If you've got a device that's capable of running Android or capable of running Linux, you're probably not going to be using our tools. You can, and some people do. So people have built, server products on top of us. People are building certainly Raspberry Pi products on top of us. But we're really both the engine and the SDK are optimized around really small memory footprint and really limited CPU power. And so while the Moddable SDK works in those environments, I would suggest that there's probably a better solution. And there was something in the middle there that I think I lost.
I kind of rambled a little bit, but yeah, that makes sense because I guess so. There's a lot. So the embedded world is basically running right smack dab into there's different granularities to the layers for embedded right now. But they're basically trying to all merge together because what's happening is that you can, for the same price as what used to be an 8-bit processor, you can get a full-fledged dual-core 32-bit processor with twice the memory. So like the differentiation between like why would you even run an 8-bit processor anymore? The edge cases for running an 8-bit processor almost evaporate. When you want to do at least two different things. And I'm making statements. I'm being a little flippant, but at the same time, like a lot of the ARM processors, they do have their own gradations, but a lot of them, there's still a lot of room in between the two, like a full-fledged Linux processor versus basically, well, normally in the embedded world or in the industrial world, like a programming logic controller, a PLC device, which is basically a really limited resource intense device that does nothing but do like process control that comes in and make sure it happens at a particular order and at a particular rate. So I guess what I'm asking for is, it sounds like Moddable SDK is really good for like sensor ingestion. But if I wanted like a true blue PLC device, I'd almost need to have like access to the real-time operating system underneath the JavaScript. I'm not sure if those. I don't think even JavaScript handles like concurrency and semaphores and like processor weights and threads. Or maybe I'm wrong about that. I've not done a lot of JavaScript, but I don't think it's really the language for doing heavy event-based coding. I guess what it comes down to.
So it's excellent for doing event-based coding if it doesn't need to be real time.
Yeah.
Where you get into trouble is with real-time processing of things. And so what we actually typically do there is, so XS as a JavaScript engine allows arbitrary blends of script and native code, generally speaking C, but it can be C++ depending on the platform that we're running on. And for instance, on the ESP32, we frequently will spin up an extra RTOS task in native code, bind that to a JavaScript module, and then do some sensor ingestion or synthesis before events go back up to the JavaScript level. So we often will like catch, if you've got events coming in 100 times a second or something, triggering an interrupt, we'll catch all of that in the native code, process it, save it in native code, and then on conditions or on aggregation or on a timer or whatever, bubble that up to the JavaScript layer. And that's kind of the blend of real-time processing and script that we end up using a lot.
Okay. So it sounds like, but you do allow to do like C modules, for example. So,
yeah. So a JavaScript. So every module in our system needs to have a JavaScript module representation, which in our case usually just means like a constructor that has a name, right? So that you can go out and build the object. But then the entire implementation of that JavaScript object might be in C.
That makes sense. So
often is.
So to basically do what I want to do is essentially I basically wrap a what would you call it? Like basically a pre-order TOS task in a C package, and then put the hooks in there to be able to call it from Moddable.
Yep.
And so what will end up happening is that all the real-time operating system stuff I need to do, I do it inside that module, and then the asynchronous calling of that would happen from the JavaScript layer.
Correct.
So in a lot of ways that works kind of like how I think Python would do it, and some of the other languages would do it, as they would basically call like resource specific or resource constrained like C code, and then use the JavaScript or in another case Python as the scripting language to run your application.
Yep. So you can basically do an arbitrary mix of that depending on what your needs are. If you're staying mostly in things that we have good, script bindings for, which is kind of graphics, network, that sort of world, then you can stay all up in script. But if you need properties of a particular RTOS or of the particular hardware, you go drop into native code and just build a kind of minimal JavaScript binding to it. That's your nerd JavaScript tech talk of the day.
So yeah, so what it really comes down to, so the other nice thing about this is that this really kind of comes back down to like, how do you, there's like a bajillion different ways of using embedded. So this is how you basically let you do most of that really fine-grained detailed stuff, but still then taking advantage of all the features that Moddable has already. So like a lot of things that get left on the cutting floor on a lot of embedded devices is all the user interaction portion of it. This is one of the reasons why a lot of those embedded devices have very rudimentary, if any, user interface. And if it is, then it's usually kind of packed together. So I think that part gets really exciting. I don't know if it's this project or another project, but it had some interesting examples of doing like user interface GUI interfaces with like a no-code, low-code application, and to be able to actually do all that, and then on top of that, having some of the lower-level embedded stuff. So where I'd see with this would be like an access control. You'd have a screen. You'd have like a low-resource, low-cost embedded processor. You'd have the screen controlling a series of sensors on the device. And then on top of it, it would also have like a web interface as well as maybe another lower level interface for talking to the individual sensors directly. So really exciting stuff.
Yeah, and if anybody's interested in checking out kind of graphics using the Moddable SDK, so a lot of what we do is actually screens and providing user interfaces on things like thermostats and washing machines, household products. And so we sell a couple little devices that we hand assemble and we sell them at cost that are just kind of a screen and an ESP8266 or a screen and a ESP32 kind of stuck together. They're called Moddable 1, Moddable 2, and Moddable 3. And if you go to our website, if you're interested in trying a nice touchscreen with an ESP32, that's a good way to do it.
Very cool.
I was just going to say, it's interesting too, because there's a very common situation where they'll have an in-room controller in these grow environments that have a touch screen, and they don't have any way to access anything outside of that room. So I think that inevitably, as you start to have like on-premise controller devices, I think touch screens are kind of like some kind of user interface on premises is sort of a requirement. An example would be we were talking about, myself and Lawrence were talking about how to do light controllers in particular. And light controllers are an interesting one because it's fairly simple to just set up a rule upstream in the cloud to say, hey, we want you to be on for 12 hours and 12 on. But you also need to have fallback mechanisms, because if you leave a light on for 36 hours straight, you're very likely to burn your plants, regardless of what kind of plants they are. So there has to be something on premise that would be able to be a fallback mechanism for that. And we've looked at a Raspberry Pi, for instance, and other devices, but I always imagine that at some point, those kinds of controlling devices likely have to have some kind of user interface. And I like that Moddable in particular has focused quite a bit on the user interface stuff. A lot of the documentation examples in the book, for instance, use the user interfaces and the Moddable 1 and Moddable 2. I don't know if I saw Moddable 3 in there. There might have been a Moddable 3 in there. But I like that quite a bit. Resources, of course, become an issue because PNGs can get huge and so forth and so on. But I really like that. That's shown for me in particular if I was going to pick a direction for that kind of product.
If you ever find yourself in sunny Palo Alto, California, stop by our office. We've got a bunch of lighting controller demos set up around the office because it is kind of a natural, here we're talking about room lighting, but it's a natural use of the technology to have the touch screen available for being both a light switch and doing programming on there, but then also to pair with a website or a phone and do scheduling and creation of scenes and that sort of thing. So we've done a lot of that work.
Yeah, actually, I was talking to a friend of mine who bought a bunch of Philips Hue bulbs and then bought a lot of third-party bulbs, and they use two separate interfaces. There's no one solution that will allow them to speak to each other.
There is one solution that allows them to speak to each other. We wrote it. It's in, so our CEO, Peter, has a private GitHub or his own GitHub repo, but he's hell on lighting controlling right now. And he wrote a JavaScript mediator that knows how to talk to all 10 different brands of smart light bulbs and make it like they all speak the Philips Hue language.
That is awesome. You know, I was it's so crazy too, because I sent Lawrence a digital ballast, and it has the ability to be like digitally controlled, but most of the actual receptacles don't allow you to do digital dimming. And then a lot of the LED devices you buy for grows, for instance, and this is I know we're in Oklahoma, so this is like Smokelahoma nowadays. Everything is cannabis, but not just in cannabis, but in leafy greens as well. A lot of these LED drivers, like they completely fully have the capability of doing something like dimming, and then they just don't actually let you dim. And that is a really powerful thing to have for like energy consumption, and also doing like timing at different points in the year. And I think some big brands like Kind LED and some of the really expensive devices actually have, you know, sensors that, you know, if you get 12 hours of sun and you need 14, the light will kick on for 2 hours at a certain spectrum, and then so forth and so on. But it's like there's no reason why someone shouldn't just be able to go buy a $40 controller and a sensor and just do that on their own. It just kind of drives me crazy that, you know, people are spending $5,000 to $10,000 for. Now the lights are, you know, LEDs are expensive if you want really good ones, but like that solution being so, just grinds my gears, Andy, grinds my gears, that like nobody really wants to like not take the $10 million from the venture capitalists and want you to like 10x their product. They just want you to like, just don't do it. Just like, let's get everybody's house should have like automated lights by now. It's time. Like everybody's house, like there's no reason why like everybody's house should have automated lights. That's my opinion.
Yeah, and I'm just to roll it all right back around. A lot of these manufacturers don't own their own designs for like the ballasts. Usually they're buying white labeled OEM devices, and then they're integrating them into their own products. So a lot of these products actually have features that are being left on the cutting floor because either they don't want to go through the process of figuring out how to integrate in a wireless device, and then having to figure out how to integrate that into some kind of like controlling app, and then having to figure out how to control like basically like the vertical stack that you have to do to get from your phone, push a button, turn on the lights is enormous. And a lot of manufacturers don't want to go that route, so they usually will just leave those features kind of like as a feature that they never talk about, and it's just kind of covered up. Or they go through the route of doing it, and then they charge 2 arms and 2 legs because it costs them a whole body or several man hours to actually get the whole thing put together. And then very few people actually are able to do it correctly, and very few people are willing to then take their implementation and then give it away for free. So everybody's got these half-baked home automation configurations, and it's crazy because if there was a way of making this easier to do, it would basically allow us to have, like Daniel said, lights that were controllable and easy to turn off and on, and not have to hack something together yourself. So.
And you don't have to worry about, I'm going to go back to ground my gears. You don't have to worry about your light listening to the Amazon Prime driver driving down the street, right? Like that's, or like sucking all the data from your data package. And that's, you know, as my company grows, it's becoming more and more important that we support a lot of different opportunities across the world. And one of them is like in India, where they have really restrictive data packages, right? Like you get so much data, and imagine sending like an Amazon Echo to your friend in India, and then like it's trying to like track Prime drivers, and it's just sucking all their data. They pay a lot of money for that. You know, they have really strict data restrictions and data caps. So yeah, that's guys. It's what is it like? It reminds me of that meme where it says like I laughed, then my toaster laughed, and then like he shot his toaster. Reminds me of that. We're almost at time, Lawrence. Anything else we got? Any other questions? We got Warren. Warren is got a master's degree in, I believe, math and does machine learning. I'm going to call you out, Warren.
Yep, that's me.
You also work for a software consultancy. Like, think of all the cool things. You could build the next Kindle, and it could run Mobi and PDF and EPUB files. Yay, finally, we have one reader that can rule them all. Come on, Warren.
Yeah. Yeah, we've looked into actually doing image recognitions for document uploads, like doing some neural nets to try to make that faster, but just doing full stack development right now.
Yeah, OCR is hard. That's a hard problem to solve. One thing, I mean, I don't know if I talked to you about this, Warren, but I definitely talked to Lawrence about it, which was running the new ML on the edge now, which is for doing like real-time image processing. Because something my machine learning expert at my company was talking about was like taking pictures at a certain time on a certain plant over a course of time to be able to track its progress and hopefully get good enough to be able to make some predictions based off of that information. Right now we can do that pretty well with just normal weight stuff, but imagine they do one of the sciencey things. Oh Lord, here we go. One of the tests that they can do is a leaf analysis, and they will like shine infrared light through it, and they'll take a look at the veins and the cellular structure. Imagine you could actually do that on premise. That would be neat. Or you know, any of the sort. I'm telling you, machine learning on the edge. You never know.
Yeah, I mean, right now it's actually constrained between like maybe 2 or 3 major companies. And even if you wanted to, the hardware unfortunately required for right now is pretty expensive, because your 2 options are for doing full models is running off of like an NVIDIA Jetson or something similar to that, or doing like an FPGA processor that's running a particular model. You can use some of the baked-in ones that like Google has, either Google Coral or Intel has a Mobius, I think, for their hardware. But those are all, a lot of those are designed for models that are pre-computed from a large data set that's been like aggregated and then streamlined and then cleaned up and then run through. And then you shrink the model down and you put it onto the edge devices, and then it runs like a particular model. The one I'm more interested in right now is the edge learning, because you get basically, it's a little bit more problematic because you don't have as many resources, but the amount of data you're able to collect and process and go through is enormous. And the fact that you don't have to then send across raw data, you can just send across the updated models, would be really powerful in edge devices that have data constrained environments, and has a lot of. I'm really interested in seeing that happen. Not entirely sure how to do it yet, but it's something I'd really be interested in seeing happen.
Cool. Well, that's all that I got. We got a really cool surprise today. We have with Andy and Lizzie both. Appreciate you for popping in. That was super unexpected, and it's hard not to fangirl a little bit and, you know, just profusely sweat when you're giving a talk about a product that you spent probably a collective of about 20 hours working with. So I appreciate you very much for popping in and listening to me talk today.
Thank you for having us. I appreciate you tagging us on Twitter so that we know this was going on. And if anybody's got any questions or wants to try things out, hit us up on Gitter or open an issue on GitHub or join us on our GitHub discussions. Everything's there and open source and waiting for you to check out. So thanks for having us.
Very cool. Thank you.
Yeah, thank you very much.
Yeah, thank you so much.
All right. Well, I guess I think James has got the video, so we'll probably have this up in maybe a week or so. And thank you everybody for showing up. This is Oklahoma Open Source Hardware Group. And if you have any questions or want to find us again, we're on the Techlahoma Slack. And next, we'll figure out what we're doing for next week at a later date. But it's usually, it varies. So. But yeah, thank you. If anybody has any questions, feel free to put them on the Slack or just shout them out now before I shut things down.
Also, thank you, Lawrence, for letting web dev come on and take over the hardware.
Well, yeah, web dev light. There's hardware somewhere underneath all of that web dev, always. Well, cool. Well, have a rest of the weekend. And I guess we're gonna, James, if you want to shut it down, we'll call it great. Call it done.
Thank you, James. Thank you, Lawrence.